Good morning. My name is James Little from Mass Spec Interpretation Services. I'm doing a course on data processing using the Thermo Freestyle software with the NIST MSMS search for compound identifications. A key part of that is getting elemental composition using the Freestyle software with the very high quality Orbitrap LCMS data. With that, you get excellent, accurate mass to charge measurements that one can use for molecular formula determinations, but also you get excellent isotope ratios. And by using both of these, you can you can minimize the number of hits in the final results list. So that's very, very powerful approach to doing these molecular formula determinations. I'll demonstrate it today with Tenevin 234, which has a molecular weight of 447 and a molecular formula of C30, H29, N3O. And so, of course, in the positive ion LCMS data, we'll get a 448 ion with accurate mass decimal places to the right of the decimal. And likewise, we'll get an M minus H in the negative ion mode at 446. So 446 negative, 448 positive. So let's go to the software and try it now. So we'll open up the Freestyle software. I've already brought in the data, like I showed you how to process it by my preferred mode, where you automatically have all the information that you want in the top. So here is our positive ion trace. This is our negative ion trace or chromatogram. And it'd be hard to tell with all this chemical noise where the negative is, but we'll use the diode array to kind of pinpoint what we're looking for because we know what we're looking for has a nice UV absorption in this case. And what we'll do is we'll go up and we'll click on the positive, left click on it, and it sends the accurate mass to the spectrum window here. You can see the nice isotope ratios that are here, and we've got the accurate mass. Normally one would have the scans over here, but we'll go up here to the top and go to the elemental tab. And we'll put it in peak picking mode and go to pick our peak. So we pick the 448.2377. It puts it up in the window up here, so you can see it transferred it into this window. And now we set up our different elements we want that are reasonable and say calculate. You can see the best hit is the C30, H30 oxygen with 3 nitrogens. And of course, this is the protonated species, so the actual molecular formula would be 1 less hydrogen. It has a very good fit overall, very low difference in the millimass units between the theoretical and the observed. If you look at the combined score with the isotope ratios and the accurate mass data, it's the highest at 99.35. So some other things you might have to consider, but they fall off a little bit here, but it is the highest. But you have to be a little careful about just picking something, about studying about your sample matrix and the type of sample you're running. But it was the top one here in this particular case. And the number of isotopes were 4, and it missed 0. So it had very good isotope ratios for the pose formula also. So let's see if we can get some corresponding data from the negative ions. So I'll click on the negative ion chromatogram. You can see the 446. Click on it to bring it up. Rescale it. I just clicked on the wrong thing. So I'll go up here, and I've got what I want. Pick peaking. I'll pick the 446 ion to accurate mass and say calculate. And again, C30H28ON3. So this is minus a hydrogen. So it'd actually be H29 for the species. A good fit. Very small difference in the millimass units, even for this very small overall signal. And you can see the theoretical mass versus the accurate mass looks very good. Only a small difference. Look at the isotope ratios. The number of isotopes matched were 4. Didn't miss any. So again, we use both of these pieces of data to indicate that it's 447 is the molecular weight, and the molecular formula is determined. And then we can carry that information to the MSMS search and use those limiting values and the associated data we get from that and model compounds from there to propose the structure. So I hope this course has been useful to you in your work, and I hope you can use it to solve real world problems for yourself. Good day.